Okay, this lesson is going to be titled Algebraic Expressions, and basically we're going to go over a few different examples, essentially trying to write algebraic expressions in terms of English, so you can kind of figure out how to do word problems. This is a very basic introduction to word problems. So let's just cut right to the chase and just do a couple of quick examples. If you see something like x plus 3, just in general, just written down on a piece of paper somewhere, what does that translate to in English? Just as an example. Well, that would mean something like 3 greater than x, for instance. But typically the way you'll see it in word problems is something like the sum of x and 3. Typically you'll see it written something kind of like that. So if you see something like in a word problem, the sum of x and 3 or whatever, just focus on the word sum. Sum means addition. Okay. What if you see something like x over y written down in math somewhere? Typically, in terms of word problems, this typically translates to something like the quotient of x divided by y. Quotient is the term meaning division. So I'm trying to help you focus on these words that translate into definite things in algebra. So when you see the word quotient, you should be thinking division. When you see the word sum, you should be thinking addition. Now what if you have something like 2xy, which we've learned by now in algebra, that just means 2 times x times y. Well, in terms of word problems in English, that would look like something like the product of 2x and y. In this case, the key word is the product. The three main things to look for here is the sum, which means addition, the quotient, which means division, and the product, which means multiplication. And also, I'll just tell you, I haven't done a specific problem yet, but if you see something like x minus 3, the key word there is the difference. So you have sum for sum, difference for difference. So that would be like the difference between x and 3, or 3 less than 3, or something like that, would typically mean subtraction. So let me just erase this real fast, and we'll just do a couple of other examples to make it clear. So if you just pick up on the keywords, if you're given a word problem, and we're going to do some word problems as we go through the course here, really the trick is translating the thing. Once you get the thing translated into math, it just becomes a math problem. So it's really not too bad. Alright, so let's do something just a tad more difficult. What if you had something like 5 over x plus y? Well, I know right away that somewhere in there I'm going to have the word quotient, because I've definitely got some division going on, and we learned from the previous page division is quotient, the word quotient tagged onto that. Somewhere also in here we're going to have the word sum or summation or greater than or something like that, because we've got some addition going on. So typically if you were to see this written out in words, it would look something like the quotient of 5 divided by the sum of x and y. The quotient of 5 divided by the sum of x and y. So pretend you don't even see this, and this is your word problem. The quotient of 5 divided by the sum of x and y. Well, you're taking 5 and you're dividing it by a sum. So then you've got to put it like this. And of course we've learned from the other problems that there's kind of an implied parentheses here. So the sum of x and y is sort of done first before you actually do this division here. And that's why it's written this way. Okay? And what if you had something that looked like x, y, parentheses, x plus y? Well, algebraically, we know what we're doing here. We multiply x and y, we get that number, and then we take the sum of x plus y, we get that number, and then we take those two numbers, the two that we just calculated, and we multiply them together, and we get the answer. So we know we're going to have the word product somewhere in our English translation, and we know that we're going to have the word sum somewhere. So this is going to look something like the product of x, y, and the sum of x and y. Now read that a few times. The product of x, y, and the sum of x and y. And that's exactly what we have here. Product of x and y, and as the final term, the sum of x and y. And that's exactly what we have there. Okay, so now that we've done it in that order, I'm just going to pick a couple of quick ones that we'll go ahead and do in the reverse order, and then we'll move on to something a little bit different in this section. But I want to go in reverse order real fast just to show you, what that's all about. So what if I had something that looked like, let's see, what if I had something that looked like, in a word problem, the quotient obtained, and I'm going to write that as obtained, when the product of 3, and I'm going to write this 3 and z, is divided by the product of 4 and x. Okay, so let's read that. The quotient obtained when the product of 3 and z is divided by the product of 4 and x. So let's pretend that you're not very good at this kind of thing, and we just wanted to tackle it. Well, first of all, it tells me that somewhere in this expression here I have a product of 3 and z. The product, as we've talked about in the previous couple of charts, product is multiplication. So somewhere I'm going to have a term that's going to look like 3 times z. I know I'm going to have that term because it says I have the product of 3 and z. In addition to that, it also talks about the product of 4 and x. So I know I'm going to have a product of 4 and x, which is simply 4x. And then the main part of the problem says that the expression is the quotient obtained when the product of 3 and z, which is this, is divided by the product of 4 and x, which is this. So the quotient is division, okay? So when you put it all together, the quotient obtained when 3z, which is the product of 3 and z, is divided by 4x. And that's exactly what the answer is going to be. And if you read that in terms of English, the quotient obtained, the quotient of the division, when the product of 3 and z is divided by the product of 4 and x. So it's not too bad. You just have to take it kind of one step at a time. And just kind of, if you don't know exactly where to go with the final answer, don't start writing down the final answer. Just break it into parts. And I can't stress this enough when I tutor physics and calculus and other areas. Write down what you know and try to solve part of that before trying to tackle what you don't know. Okay. What if I had something like, as an algebraic expression, the number obtained, I'm going to write that as obtained, when the product of x and y is divided by the sum of x and z. So just read it a few times. The number obtained when the product of x and y is divided by the sum of x and z. So I know I'm going to have a term that involves the product of x and y, which is simply x times y. I also know I'm going to have a term that involves the sum of x and z. The sum is addition, so that's x plus z. And then the problem says that I'm going to be getting the product, actually the number obtained when the product of x and y is divided by the sum of y of x and z. So I have this term x and y being divided by the sum of x and z. So it's going to look like x times y, which is this big term they talk about here, divided by this term on the bottom, x plus z, all as one whole unit. And that's what the answer is going to be. So you find kind of like your individual subterms, and then go back to the problem to figure out what they're really asking for if you get stuck. Okay, that's really all I want to do. I mean, we could go over problem after problem after problem. All the different word problems are going to be different, but the fundamental point is really going to be the same. You got to focus on those keywords. There's really 4 of them. What are they? Sum, product, difference, quotient. Remember those 4, and you'll be good to go. Now let's move on a little bit here. The topic of this section, of course, is algebraic expressions. An expression is just kind of like a group of terms, really, kind of like a part of an equation. An equation consists of a bunch of expressions, let's say. So I want to talk a little bit about coefficients because teachers like to ask this kind of thing on exams. Let's take a very simple expression. 6d, where d is a variable. This is an expression. It's very simple. It's 6 times d. d is some number. d could be 10, d could be 1, d could be negative 5, d could be 1/5. It could be anything. But that's an expression. And one thing that they like to ask on exams is for you to find the coefficient of whatever term in the equation there. So this is a term in the equation, and the coefficient of this term is 6. The coefficient is kind of like the number out in front of all the letters, really is all you really need to worry about. When someone says, what's the coefficient of a term, all you got to do is look at the number sitting out in front of all the letters, and that is the coefficient. The coefficient in this case is 6. So let's just do a couple of additionals. What if I have an expression that looks like negative x times y plus, scratch that, minus 4t plus 35. So first of all, how many terms do we have? A term is a grouping of things that are kind of multiplied or divided. So in this case, we have 3 terms. This is a term, this is a term, and this is a term. And we're just going to see by example that groupings of things are basically terms. So there are 3 terms in this expression. And if you want to say, well, what's the coefficient? The coefficient of the leading term of the first term, notice that we have x times y, and there's just a negative sign out there. Well, what's the coefficient there? In this case, it was easy. There was a 6, so I told you the number is the coefficient. Well, see, anytime there's a negative, that implies that there's kind of like a negative 1 sitting out here. Negative just means negative 1 multiplied by this. So the coefficient of this guy is negative 1. And just for learning purposes, the coefficient of this guy is negative 4 because it's the number sitting out there. Now, it's negative xy minus 4, but this is kind of like the coefficient sitting out there. Okay? And this is the coefficient sitting out there where a negative 1's implied. Okay, so let's continue. Let's look at one that looks like negative 4xyz plus 7xy minus z. How many terms are there in this expression? Again, there are three. This is a term, this is a term, and this is a term. So we'll write over here 3 terms. What's the coefficient of this term? It's the leading number. The coefficient here is negative 4. What's the coefficient here? The coefficient of this term is 7. And what's the coefficient of this term? There's an implied minus 1 out here, so it's a negative 1. And these exercises kind of seem kind of silly, but it's important to know the terminology. And in this part in the course, we're trying to establish what is a coefficient and what is an expression and what is a term. For doing these problems rapid fire, like just writing something down and asking, I ask you what it is and then we write it down, it really doesn't much matter. But later on, when we get to quadratic equations, solving equations, finding talking about polynomials and things, it's going to be important to know what this terminology is. It's going to become very important actually to know what a coefficient is and things. Let me pick one more real fast. 3x, I'm just going to throw something in here, new squared plus 4y plus 2z plus 2. How many terms are there? How many terms are there in this expression? There are 4 terms. Here's a term, here's a term, here's a term, and here's a term. The coefficient here is 3. The coefficient here is 4. The coefficient here is 2. And the coefficient here is 2. And actually, this is the simplest case where the coefficient is the number itself. So that's really all I wanted to do with actually learning how to establish what the coefficients are and looking at the different terms. And there's one final type of problem I want to do in this section to kind of explain some terminology, and that's the following. Consider this kind of algebraic expression. What if we have 29 times xyz plus 23 times xy plus 19x. This is an expression. It's a group of terms. There's 3 terms. Here's a term, here's a term, and here's a term. And then the question is, what are the factors of the third term? Factors of third term. Okay, factors of the third term. You'll see this sometimes in your textbook, some questions. They'll give you an equation or a term or an expression, and they'll say, give me the factors of the third term. Factors, what does that mean? Factors are things that, and you'll see factors all through algebra. We are going to cover factors until you're blue in the face. Things that multiply together. Basically, it's things that multiply together. The third term is this guy right here. Okay, the factors here are 19 and x. They are both factors. All it means is it's kind of like, think of like a factor, like if I don't make it to the grocery store today, I drove there and I was late. The factors that were made me late was traffic was a factor, my car didn't start was a factor, maybe I ran over a dog, that was a factor. Okay. Those are the 3 factors that went into the fact that I didn't even make it to the grocery store today. Well, the factor in terms in algebra are basically everything that are kind of wrapped up in here that are multiplied together. That's a factor. It seems like a real dinky thing to define, but later on we're gonna intentionally factor things, and it's going to be important to know that that's the case. So the factors of the third term are 19 and x. What are the factors of the first term? Well, what is it? What is everything multiplied together to give me this expression, this little term right here? Well, we've got 29 in there, We've got x in there, we've got y in there, and we've got z in there. And they all multiply together, so they're all factors. So that's what a factor is. That's going to about do it for this section on algebraic expressions. It wasn't a very difficult section, but we had to lay down some definitions that we're going to use as we go through the course. And we'll pick it up with the next section, the properties of real numbers.